Hi, in this session I will be discussing one of the most important theorems in statistics, that is central limit theorem, or CLT in short. Let me first describe central limit theorem. Let us assume that we have a population with several records in the population. From this population we draw several samples. Let the samples be S1, S2 and so on, Sk. So, I am drawing k samples and I am going to assume that the size of this sample is n. That is, each of these samples have n records, and I am also going to assume that it is drawn from a population which is independent and identically distributed, and I will make further assumption that the mean of the population is mu and standard deviation is sigma. So, let me repeat once again. We are looking at a population. So, this is the population where the records are independent and identically distributed, and the mean of the population is mu and the standard deviation is sigma. From this population we are drawing several samples. So, here I have shown k samples and the size of this sample is n, that is, each of these samples have n records. Once we have these samples S1, S2 up to Sk, we calculate or estimate the mean from each of these samples. So, let the sample mean be x1 bar from sample 1, x2 bar from sample 2 and so on, and xk bar from sample Sk. We have samples S1, S2 up to Sk, and we are calculating the mean from each of these samples. So, the mean from sample S1 is x1 bar, mean from sample S2 is x2 bar, and mean from sample Sk is xk bar. So, these values now constitute a distribution. Basically what I am saying is we have different values of mean coming from different samples. This distribution is called sampling distribution. So, the sampling distribution formed by the sample means, which is x1 bar, x2 bar, etc. up to xk bar, will follow a normal distribution. So, this is basically a sampling distribution. And central limit theorem says that the sampling distribution in this case will follow a normal distribution. With mean mu and standard deviation sigma divided by under root n. So, basically the normal distribution, this normal distribution will have a mean which is mu, same as the population mean, and the standard deviation of the sampling distribution will be sigma divided by under root n. So, the standard deviation where sigma is the standard deviation of the population and n is the sample size. The use of the term central limit theorem dates back to the work by George Polya. Several proofs exist for central limit theorem, starting from the proof by Laplace in the 18th century and further works by Poisson and Cauchy. In simple terms, The central limit theorem states that for a large sample drawn from a population with mean mu and standard deviation sigma, the sampling distribution of sample means x bar follows an approximate normal distribution with mean mu and standard deviation sigma divided by under root n, which is called standard error, irrespective of the distribution of the population. That is, I started this session by assuming a population where I said we have population with several records, and the central limit theorem is valid irrespective of the distribution of this population. What do I mean by that? The population may follow uniform distribution or exponential distribution or normal, variable, and so on. Irrespective of the population's distribution, the result is valid. That is, the sampling distribution will follow a normal distribution with mean mu and standard deviation sigma divided by under root n. There are different versions of central limit theorem. Let me state one of them. Let us assume that x1, x2 up to xn are n random variables that are independent and identically distributed with mean mu and standard deviation sigma. So that is, x1 is a random variable, x2 is another random variable, and so on. Xn is another random variable. I am going to assume that these random variables are independent and identically distributed. Okay, so what does this independence actually means? So we already discussed independence of events. So independent basically means your probability of x1 intersection x2 is same as probability of x1 times probability of x2. Identical distribution means they are coming from an identically distributed population where the mean is mu and standard deviation is sigma. Right. So we now define n independent and identically distributed random variables. I am going to take the average of these random variables. So let us say x bar is x1 plus x2 up to xn and divide this with n. So that is the average of these random variables. Now this average follows a normal distribution with mean mu and standard deviation sigma divided by under root n. Now let us look at some of the properties of central limit theorem. We know that the sampling distribution of mean follows a normal distribution with mean same as the population mean mu and standard deviation is sigma under root n. If that is the case, then the value x bar minus mu divided by sigma under root n, this will follow a standard normal distribution that is, this statistic will follow a standard normal distribution where mean mu is 0 and the standard deviation is 1. So that is the first property of central limit theorem. The second property of central limit theorem is, suppose let us say I take summation of these random variables. Let Sn equal to x1 plus x2 and so on up to xn. So, I am basically taking the summation of these random variables. Then the expected value of Sn will be n times mu. The standard deviation of the summation will be sigma times under root n. Basically, this summation, which is summation of n independent and identically distributed random variables, will have a expected value or mean which is n times mu and standard deviation which is sigma times under root n. Here remember mu is the mean of the population and sigma is the standard deviation of the population. Now, once we have this structure, we can again define that for the random variable which is summation of n random variables, the statistic Sn minus n times mu divided by sigma times under root n, this will follow a standard normal distribution. The third property is that regardless of the population distribution, the sampling distribution of a large sample, we assume that if the number of records is greater than 30, then we assume it is a large sample. We will follow a normal distribution with mean equal to the population mean and standard error sigma divided by under root n. Central limit theorem is the basis for hypothesis tests such as z-test and t-test and so on. In many cases, we will have access to only a sample and inference about the population must be made based on the sample statistic. An important assumption of central limit theorem is that the random variables have to be independent and identically distributed. If they are not independent and identically distributed, then the central limit theorem is not valid, and many of the hypothesis tests that we may do using z-test and t-test is not valid. And this plays an important role because the feature selection in statistical learning algorithm is based on hypothesis testing, which itself is based on central limit theorem.